My name is Miss Jones. I teach elementary school math, and welcome to my channel, Miss Math Jones. Today we're going to be working on our third grade Eureka Module 3, Lesson 20 homework. The objective for the homework is to use concrete models to represent two-digit by one-digit multiplication. An example of that would be 25 times 3. Let's go ahead and get started with our homework with number 1. Now, number 1 of our homework is actually an example. But let's read the instructions to see what we're supposed to be doing. It says, use your place value discs and charts to represent the following expressions. Record your work on the place value chart shown. Then record the partial products vertically. Problem A below is done for you. So anytime I see a multiplication problem, I like to go ahead and create a get chart on top of the multiplication problem just so that I can see what my groups are, what my each number is, and try to imagine what my total will be. So we're looking at B, and the equation for B is 3 times 26. Well, as you know, when you have a multiplication equation, it's rows times columns equals total, which means we should have 3 rows of 26. So I want you to write a get chart above your equation for letter B, just like I've done here on the screen. And after you write your get chart above your equation, I want you to go ahead and create 3 rows of 26 in this place value chart. That's my first row of 26. I did 2 10s in the tens place and a 1 and a 5 in the ones place. So I want you to record your numbers the exact same way, or your place value discs the exact same way. So I have 1 row of 26. I need 3 rows. That's my second row. And now I have my third row. So now I have 3 rows of 26. Now let's go ahead and write the equation next to the place value chart so that we can start solving. Okay, first we're going to talk about our 3 rows of 6. And those 3 rows of 6 is how we're going to multiply our ones place, 3 times 6. Well, 3 times 6 is 18. And that represents our 3 rows of 6 in the ones place. Now again, everything that's on my screen, you should be writing on your paper. Now let's look at the tens place. In the tens place, we have 3 rows of 20. That's represented when we multiply the 3 times the 2 in the tens place. 3 times 20, or 3 rows of 20, is 60. Now we're going to put our answer from our tens place and our ones place together. We're going to combine it. We're going to add it to get the sum. So 18 plus 60. We work the ones place first. 8 plus 0 is 8. And in the tens place, we have 1 plus 6, which is 7. So our answer for 26 times 3, or 3 times 26, is 78. Now, if you need to pause the video to write this down or check your work, go ahead and do so now. Let's look at letter C. The equation for letter C is 3 times 43. Well, the first thing I want you to do is create a get chart right there above your equation for letter C. Now, because we have our get chart and we know that in equations that are multiplication, we should read it as rows times columns equals the total. So that means we should have 3 rows of 43. And we're going to create that in our place value chart. So we're going to use 10 discs for the 40 and 1 discs for the 3. So you need to create 3 rows just like that because you need 3 rows of 43. That's our first row. Let's create our second row. 10, 20, 30, 40, 41, 42, 43. That's 2 rows of 43. Now for our third row. 10, 20, 30, 40, 41, 42, 43. So now we have 3 rows of 43. Now let's go ahead and write our equation so that we can solve it. 43 times 3. Well, let's multiply the ones place first. 3 times 3. We have 3 rows of 3. 3 times 3 is 9. Now we're going to multiply our rows times the digit in the tens place, which is a 4. So we have 3 rows of 40, right? And 3 times 4 is 12, which means 3 times 40 is 120. And that represents our 3 rows of 40. Now we're going to combine our product, our answer, for our ones place and our tens place. So that means we're going to add 9 plus 120. Let's work our ones place first. 9 plus 0 is 9. The only thing in our tens place is a 2, so we just bring that down. And the only thing in our hundreds place is a 1, so we write that down. So that means that 43 times 3 is 129. If you need to pause it now to finish writing your information for letter C, go ahead and do that now. Now let's look at letter D. 4 times 43. Again, go ahead and create your get chart above that equation of 4 times 43. Now remember, your get chart shows you your groups, your each, your total. But it also represents rows times columns equals total. And that means we should have 4 rows of 43. We're going to create 4 rows of 43 in this place value chart. Let's go ahead and create those 4 rows of 43. 10, 20, 30, 40, 41, 42, 43. That's our first row of 43. Now let's go ahead and create our second row of 43. 10, 20, 30, 40, 41, 42, 43. Now for our third row of 43, 10, 20, 30, 40, 41, 42, 43. And for our final row of 43, 10, 20, 30, 40, 41, 42, 43. Now, we've created 4 rows of 43 in our place value chart. Let's go ahead and solve our equation. So we set it up as 43 times 4. First, we're going to multiply our numbers in the ones place. And really, you can count your place value discs to get the answer, right? So 4 times 3 is 12. That's the same thing as those 4 rows of 3 that we have in our place value chart. Now let's multiply our tens place. We multiply our single digit at the bottom times our tens place digit at the top. So we have 4 rows of 40. And what we can do is think about it as 4 times 4, which is 16. So if 4 times 4 is 16, then 4 times 40 would be 160. So 4 rows of 40 are equal to 160. Now we're going to combine the answers from our tens place and our ones place. So we're going to add 12 plus 160. Let's work the numbers in our ones place first. 2 plus 0 is 2. 1 plus 6 is 7. And 0 plus 1 is 1. So our answer to 43 times 4 is 172. If you need to pause the video to check your work or write the information down on your papers, please do so now. All right, let's look at our next problem for letter E. The equation for letter E is 4 times 65. So let's go ahead and create our get chart right there over our equation. Now remember, with multiplication equations, it's rows times columns equals total. So let's go ahead and create our rows. We should have 4 rows of 65. And instead of using 10 discs, let's use 20 discs so that they'll fit. Okay? So let's go ahead and create our first row. 20, 40, 60, and I put a 5 discs in the ones place. A 5 disc in the ones place. That's row 1. Let's go ahead and create row 2 and count by 20s as we do so. So that's 20, 40, 60, 5. Row 2 is complete. Let's go ahead and create row 3. 20, 40, 60, 5. Row 3 is complete. Let's go ahead and create row 4. 20, 40, 60, 5. Row 4 is complete. So now we can go ahead and set up our problem vertically, that means up and down, so that we can solve 65 times 4. And let's start with the ones place. In the ones place, we have 4 rows of 5. Now we can count by 5s to figure out the total. What is 4 rows of 5, or 4 times 5? What is that equal to? If you said 20, you're absolutely correct. 4 times 5, or 4 rows of 5, is equal to 20. Now let's move over to our tens place. We have 4 rows, and there are 60 in each row. 4 rows of 60. Now, you can count by 20s to figure that out. If you count by 20s, what is 4 rows of 60 equal to? Or 4 times 60? If you said 240, you're correct. 4 times 60, or 4 rows of 60, is equal to 240. Now what we're going to do is we're going to put our total for our ones place and our tens place together. So let's start by adding the ones place. 0 plus 0. Well, that's 0. 2 plus 4, that's 6. And 0 plus 2 is 260. So that means that 65 times 4 is 260. Now, if you need to pause your video to check your work or just to make sure that you have everything written on your paper, go ahead and do so now. Let's go ahead and move on to letter F. The equation for letter F is 4 times 54. Now let's go ahead and place our get chart right there above our equation so that we can see our groups, each and total. And remember, in multiplication equations, it's usually rows times columns equals total, which means we should have 4 rows of 54. So what I'm going to do to make it a little easier is we're going to place 50 discs in the tens place. All right, and ones in the ones place to represent the 4. So we have 150 discs, 150 disc, and 4 1 discs. All right, so we need 4 rows like that. 4 rows. 4 rows of 54. Our first row is complete. Let's go ahead and create our second row. 50, 51, 52, 53, 54. Row 2 is complete. Let's complete row 3. 50, 51, 52, 53, 54. Row 3 is complete. Let's complete row 4. 50, 51, 52, 53, 54. All right, now that we have 4 rows of 54, let's go ahead and write our problem down vertically so that we can solve. 54 times 4. Well, let's start with our ones place. We have 4 rows of 4, or 4 times 4. What's the total for 4 rows of 4, or 4 times 4? And if you need a little help, you can count those ones discs in the ones place to get your answer. And if you said 16, you're correct. 4 times 4, or 4 rows of 4, is equal to 16. Now let's look at our tens place. We have 4 rows of 50. 4 rows of 50, or 4 times 50. Well, you can count by 50 to determine the answer. If not, you can use your knowledge of 4 times 5, which is 20, to figure out 4 times 50, because all you're doing is adding a 0 to the ones place. 4 times 50 is 200. Now let's put those two answers together to get our total. 16 plus 200. Well, let's start with our ones place. 6 plus 0 is 6. And 1 plus 0 is 1. And 0 plus 2 is 2. Which means 54 times 4 is 216. Go ahead and pause the video now if you need to finish writing, or if you need to check your answer and compare it to mine. Number 2. Number 2 says, Anna says that knowing her multiplication facts helps her find products of larger numbers. She says that knowing that 3 times 8 equals 24 and that 3 times 4 equals 12 helps her find the product of 3 times 84. What do you think Anna means? Explain your thinking in words and justify your response using partial products. I like to show my work to explain thinking. So let's start off with 3 times 84 because that's the question that she's trying to answer. 3 times 84. And we can use partial products. So let's look at the 3. Well, we're not going to break apart that 3. It's already a small number. We don't have to partially break that apart. So we leave that whole. So we're just going to bring that 3 right on down. But now that 84, we can break that apart to make it a friendlier number, or friendlier numbers to work with. So 84, well, I can take that 84 and break it into 80 plus 4. And 80 plus 4 is 84. All right, well, now that I've broken apart 84, I can take my 3 and multiply it times each number. All right, so let's go ahead and get that set up. So first, I'm going to multiply 3 times 80. Well, I know that 3 times 8 is 24, just like Anna says in her thinking. So that means that if 3 times 8 is 24, then 3 times 80 would be something that looks a lot like 24. So let's keep that in mind. But first, we're just going to write down 3 times 80, and we're going to put that in parentheses. Now we're going to add that to the other number that's there. And we're going to multiply 3 times 4. And we're going to put that in parentheses also. So now we have 3 times 80 plus 3 times 4. Now let's go ahead and solve. Now remember, Anna says that she knows that 3 times 8 equals 24. Well, if 3 times 8 equals 24, then 3 times 80 equals 240. And also in the word problem, it says that Anna knows that 3 times 4 is 12. So they gave us that answer. 3 times 4 is 12. Well, now we can combine those two answers to find the actual product of the multiplication problem of 3 times 84. So we just add 240 plus 12. Start with the ones place. What's 0 plus 2? 2. And 4 plus 1? 5. And what's 2 plus 0? 2. Perfect. All right, so we can explain what we did in words by just explaining our process. So first, we used the distributive property to break apart 84. Then we wrote down our new equations. Those new equations were 3 times 80 plus 3 times 12. Then we solved the equations in the parentheses, then added them together. So 3 times 80 was 240, and 3 times 4 is 12. So we solved them, and then we added them together. 240 plus 12 is equal to 252. So that means that 3 times 84 is 252. Now this is just one strategy to solve this problem. Very soon we're going to be looking at the standard algorithm to solve 2-digit by 1-digit multiplication problems, which is a lot less steps. All right, now you may need to pause your video to make sure that you have everything written down, or just to compare what you already have written down to my answer. Let's take a look at number 3. Mike has 41 stickers. Ruby has 3 times as many stickers as Mike. How many stickers does Ruby have? Draw a strip diagram. Use the place value chart to draw place value discs and justify your response using partial products. Okay, well, let's take it one sentence at a time. Mike has 41 stickers. So I'm going to write this information down because it's information. 41 is Mike's stickers. He has 41 stickers. Then it says Ruby has 3 times as many stickers as Mike. Okay, so what I could do is I could draw 3 boxes, right, for 3 times, and put 41 in each box because she has 3 times as many as Mike, and Mike has 41. So I'm going to go ahead and create 3 boxes with the number 41 in each box. And that strip diagram will represent Ruby stickers because Ruby has 3 times as many as Mike, or 41 times 3, which would be 3 rows of 41, or 41 rows of 3. Now, I created a place value chart, and you can too, so that you could see what 3 rows of 41 would look like in a place value chart. And if you want, you can set yours up and solve it like this also. All right, now what you could do is first count all of the tens in the tens place. And if you do that, then you would end up with 120. So that means that the tens place is worth 120. And then if you wanted to, you can count the ones in the ones place, count by ones. And if you were to do it that way, you would end up with 3. So we could combine the total from the tens place, 120, with the total of the ones place, 3. And we'd end up with the equation 120 plus 3, which equals 123. Now, many of your parents may already be showing you how to solve 2-digit by 1-digit problems using the standard algorithm, which is fine. We're going to get to that. That's my preferred way to solve problems. And as I said before, a lot of these homeworks are just showing you different strategies or different ways to solve problems. And it's okay to use a different strategy. Now, when I say standard algorithm, what I mean is you write the number or the problem vertically. For example, 41 times 3. And then you multiply this digit times each of the numbers at the top. So first we will be multiplying 3 times 1. And 3 times 1 is 3. Then we would multiply 3 times 4. And 3 times 4 is 12. So our answer is 123. Now notice that is a lot shorter to do. And that's what I mean by standard algorithm. And that's what your book means by standard algorithm. And that's what the STAR test will mean by standard algorithm. It's just setting a problem up vertically and solving it as it is. No special strategies, just like that. And that's okay. If your parents teach you how to do it that way, that's fine. As long as you get the right answer, it's fine. All right, now if you need to pause the video so that you can write down this strategy or practice the standard algorithm, go ahead and do so now. Well, lesson 20 homework is now complete. Congratulations. You finished your homework. I know you're glad. So, I hope this video has helped you. I hope you have a great rest of your day. I'll see you next time.